Jose was lost in the desert. He walked due east for 5 miles until he saw a mountain peak that he recognized. Let's draw a picture of this. So due east for 5 miles. When he turned to walk towards the mountain peak, his compass read north 20 degrees east. So north, so there's being north, and then 20 degrees of that part east. He walked in that direction for 3 miles until he found his car. All right, so our geometry, we go back to understanding here, is that this is parallel to this. So if this angle is 20, so is this angle up here. All right, and so this comes down, creating that right triangle, and this would be a right angle down here as well. All right, so this is what we know so far. We know eventually we want to know what is this distance. I'm going to put a question mark. Went due north and then to the east 20 degrees, making parallel lines. This is 20 degrees, that makes this 70 if we extend this. And then these are alternate interior with the transversal and parallel lines, making this 20 degrees. What can we do to come up with this? Well, let's look at this triangle. If I just draw this right triangle down here, and it's not drawn to scale, we know this distance is 3. We know this is 70 and this is 20. Let's go ahead and let's figure out what this distance is. So I'm just going to put an X here for now. Okay, so in comparison to 70 degrees, this would be opposite and this would be the hypotenuse. So opposite and hypotenuse are going to be from the primary trig function of sine. So sine of 70 degrees is equal to opposite over the hypotenuse. Now, to isolate this variable, I'm going to grab the calculator, make sure that I am in degrees. Excuse me. I'm going to take the sine of 70, get an answer, and take it times 3. Okay, so this length right here is approximately 2.819077862. Okay, so I know this part right here. I have found that out. I'm just going to put 2.8 now, but I'll refer to this total length later on. Now let's find out this length down below. So I never want to use a length that I've had to estimate. So I never want to do like 2.8 if I don't have to. I want to rely on exact measurement. So I know this is 3. Well, I want to figure out what is this length. Let's call this y. So in comparison to this angle, and I could use 70 degrees by the way, and I could use cosine, but in comparison to this angle, which is angle 20, I have the sine of 20 degrees equals opposite, which is y, over the hypotenuse, which is 3. And the same thing, I'm going to take the sine of 20. So sine of 20, get an answer, and take it times 3. And I have this length right here is 1.02606043. Still an estimation, right? Because it's an irrational number that keeps going on and on. So let's think about what do we have. We have this entire length. We have this entire length. We know it's a right triangle. We can figure out this final length with this hypotenuse of this triangle by doing a squared plus b squared equals c squared. So I'm going to go 5 plus this previous answer, which is right here, and I want to square it, plus I need to get this answer right here. And that was 2.819077862. I want to square that. So a squared plus c squared equals c squared, but then I want to take the square root of that to get this. So square root of that exact answer gives us approximately 6.652. That's the approximation of what this length is. How far from his starting point was his destination when he found his car? This would be the distance right here. In terms of miles, 6.652 miles. And then, okay, let me move this. To figure out the bearing, we need to know what is this angle. So from here, they're saying, how do we get to this point? So we'd go north. That's the first thing. Now I'm putting north. Now I'll figure out what this angle is. That will go in this place, and then we'd go to the east. So how do we figure out this angle? Well, we have a couple different ways we can do this. So now we know this length, and this length. So I'm going to do sine again. The sine of this unknown angle is equal to 2.819077862 over the hypotenuse, which is 6.652864338. 368. So this is going to be opposite over the hypotenuse. Remember, we use on our calculator, think of the arc sign, but we use the inverse button when we're trying to figure out what an angle measurement is. Okay, so to do this, I'm going to do inverse sine, and I want to take this value, 819, there it is, 0.777862 divided by this exact answer, which I have up above, so I can paste it in. And here we go. So now we have an angle right here of 25 degrees. Let's look this. Okay, so this is 25 degrees. I'm looking at the answer key here, but this is the actual angle. After we figure out this is the actual angle that we want to figure out. So if we have a right triangle here, here's 90, here's 25, so 25 plus 90 plus what unknown angle equals 180. So sorry there. 25 plus 90 plus one unknown angle, so 25 plus 90 plus what unknown angle? Let's take 180, subtract what we have, which is the 90 and the 25, and that's how we end up with that 65 degrees.